Hello, I'm John Lee, and I've spent most of my life building gliders of one form or another, mostly of my own design. But a pilot friend of mine recently suggested I may be interested in building a vintage glider, uh, a glider of Swiss origin. Hutter was in fact Swiss, but apparently now lives in Germany. Before going outside and looking at the main part of the project, I'd like to go into one or two details of how sailplanes are traditionally built. There is only a specific technique for building wooden aeroplanes, which was evolved before 1930, and in fact the construction technique has become classical over the years. The principle of building in wood is largely one of the most effective use of plywood, and very thin plywood at that. This particular piece that I have here is less than 1/16 of an inch thick and is the main component of sailplanes of most types. To clear up the strength problem relating to wing construction in particular and aviation components in general, we can see that plywood is not very strong at all in bending. It will snap off quite easily when folded that way. But the principle of aeroplane construction is to use plywood in shear, which means bending it as a sheet rather than as a thickness. So the problem then becomes one of the fact that, very basically, if we bend plywood in this fashion, it will buckle. You can see it's buckling there, and when it buckles it can break. Now, in order to stop plywood breaking or buckling, we add on small pieces of timber, generally speaking, to the top edge and the bottom edge. The purpose of this timber is twofold. One, it has an innate strength of its own, but the main reason for that timber being applied is that once the edge of the plywood is supported, the plywood cannot buckle and it cannot tear. In other words, it forms a border around the plywood and prevents it from being able to buckle when it's in bending in this fashion. In other words, we can say therefore that plywood is never used in aeroplanes in this direction. It is always used in the vertical plane. Now, I have a small example with me of a component built using this technique. This is in fact one of the tail surface ribs. In other words, it's in this instance it's an elevator rib, and this is the moving part of the elevator. It's not one of the leading edge portions, it's the tail rib, and it rotates in that fashion. Now you can see clearly here that it's made of very thin plywood, which is used in two forms. In one form as webbing on one side, and on the other side as gussets. Now these gussets figure very largely in wooden aircraft construction, even in cases where there is no webbing involved. There are always gussets. Now, in terms of woodwork, aeroplane construction is concerned entirely with strength factors. Unlike other forms of woodwork where beautiful joints are made and construction techniques vary considerably, in aviation there is only one technique that can be used, and that is basically the technique of joining things by means of gussets. Now these two members on the edges here called the flanges. We have flanges and webs. These are not jointed at all. They run all the way from the end to the bottom, and they are tapered at the end, and they are butt jointed at the top. You can see perhaps the butt joints there. Now, therefore, the plywood is providing the joint. In terms of any connections between woodworking aeroplanes, it is the plywood gusset that forms the joint. So, in addition to this, a lot of parts of aircraft are curved. I have here part of the end surface of the elevator. In other words, here is the rib and here is the curved end of the rudder. This is in fact an offcut. But in order to create shapes of this kind, the wood is in fact cut into 3 pieces and laminated. In other words, glued together to make one item. And possibly we can see here that that is constructed of 3 pieces. Now, a lot of the work involved in building aircraft involves laminating, and this can be a lengthy procedure if other forms of bending are involved, which can mean either pressure assisted water treatment, in other words superheated water pressurized into the timber to make it flexible, or it can normally mean simply cutting 3 small pieces that will bend very easily around the shape in a former and can then be glued as a complete set. So generally speaking, we try to avoid water treatment because that delays the process and involves waiting whilst the water dries out, because the timber must be completely dry before any assembly is carried out. So here we have an example of that bending process. This is a wing leading edge rib, and in all cases with all of my components I apply the date, which you may be able to see there, the date of construction. Now, in the case of this rib here, there is a curved member along the top inside here. This is in fact composed of 2 gussets, one on each side, with diagonal members and a vertical which goes against the wing spar. This is simply a block in the front here, and the curved member is attached to that block, and the plywood gusset then integrates the structure and makes it one very strong torsion resisting item. Now, when these are built into the wing, they're actually at 6-inch centres, or 150 millimetres to the modern person, and that means that when the wing is constructed, this part of the portion of the wing, the leading edge, is covered with plywood, and when these are at 6-inch centres, it means that as you look down inside the wing, you see an awful lot of vertical and diagonal members providing rigidity and a consistent shape, because when it comes to flying, it's a consistent shape that is needed. So we build this very accurately and very consistently and very well supported in order to provide a consistent flying surface. And the wing, of course, is the essence of the aeroplane. Great care is taken designing wing sections, and great care is taken building them to provide a consistent airflow over them. Now, I've got a set of leading edge ribs there, all dated, and I can only make at maximum 6 of these a day. I have a jig which makes 3, which we'll see when we go outside, and I have another jig which makes the tail ribs that go onto those nose ribs behind the spar. In all wings there is a spar. These are not trimmed, they are simply made ready for trimming and assembly, and they are formed onto the wing in that fashion there. The wing spar, which is 18mm thick, goes through the joint, and these are assembled on a jig. Most of the work of aeroplanes is done on jigs, and one of the problems with home building is to create economical jigs which don't enhance the cost of the overall project. Now, coming back to curved surfaces, I have with me the seat. This is the seat that goes into the H17A. This forms the base of the seat, and this curved cutout, in fact, is where the control column goes. So you can see again underneath that we have this webbing situation. We have soft plywood former here with a hard plywood gusset that goes onto the back, and the plywood is curved round and attached to formers that go across in all cases. Now, when it comes back to curved surfaces of this kind, this is 4mm thick. Sorry, it's 3mm thick, and it's made of two 1.5mm plywoods, which are not water treated because they will bend around this shape without any treatment, and they are glued up as an integrated structure in one operation. Now, when the weather is warm like it is today, that's quite an exercise to produce as quickly as that. So that's the seat, and when we go outside we'll see how this locks in to the main bulkhead which we're leaning back against. So this is the front of the aeroplane at this end, and we sit on here in a slightly reclined position because the problem with the H17A is that there's a very small amount of room underneath the wing, and our head in fact is jammed up into the gap between the wings. Not a particularly comfortable position, but then we have to consider that with sailplanes, particularly small sailplanes, we're trying to get the most from the least, and of course again the object of aviation construction is to get the most from the least. Now, at the beginning of this project we're provided with a set of working drawings, or rather they're not working drawings, they are information sheets. And I have a set of these just across the room here. Now, this is the drawing which we saw at the beginning of this film. That's called a general arrangement drawing. It gives the basic layout of the aeroplane and the essential measurements to indicate what the aeroplane is all about. This is a wing drawing, and this is the only set of information that we get with this aeroplane. It's not an awful lot of information, but the basic essentials are there. In order to interpret these drawings, we must have some basic idea of how aircraft are put together. Of course, all these drawings are in German, which adds slightly to the confusion when, of course, one doesn't understand German in the first place. This is the only other wing drawing which shows details of the wing ribs. Now we can see here again that this in fact is the nose rib, and it forms the outer of that set of lines there. We can see the wing spar in here, and we can see also the tail rib. It's not a rib that goes in the tailplane, it's called the tail rib because it forms the tail part of the wing. So we've got the leading edge and the trailing edge. These are the indicators here of the shape of the fin, the vertical fixed fin at the rear of the aeroplane, which we shall see again when we go outside. Now, the only other information we have, and this is the complete set of drawings, you can see that in fact they weren't produced in 1930, which was when the glider was designed, but they've seen rather a lot of punishment during their trip around the workshop occasionally. This is an isometric drawing which generally indicates problems where difficulties may occur, very kindly supplied by the designer, and they are relatively helpful. This is the tailplane, there is the fixed fin there, the fixed vertical fin and the rudder, and the rear end of the fuselage, and this is the elevator, the horizontal surface which forms the rest of the tailplane. Now the fuselage comes along here, and this is all the information that you get on the fuselage. So obviously with those limitations you have to produce your own working drawings from these. And in the case of the fuselage, I found that the cockpit is rather short for tall pilots, so I reproduced my own version of the drawing of the fuselage, which you can see there, and I added on 70mm into this front space here, between these two bulkheads here, which you can see. And the reason for that was that this is the rudder pedal that you can see here. And the reason I added on that length is that, in fact, when I was handed the project, I decided to go all the way down to Aston Down, where there is in fact a Hutter which was brought into England from Africa some time ago, which is currently flying down there. So I thought, well, I'd go down there and take a roller film of the general construction so that I could see where the problem areas might crop up in construction. So I have an album which I use for reference fairly extensively, and it's been very useful all the way through. Now I'll just hold up some of the pictures which you quite possibly can't see very clearly, and you can see that basically it's just a set of pictures taken to show the critical points of the design. It's always a good idea to look at originals if you're making replicas, and of course this was the idea of this exercise, was to make the aeroplane as original as possible. And of course when I got to Aston Down, what did I find? But the one flying there is not particularly original. It varies from the drawings, and in fact is probably not an H-17A. There were various other H-17s of which I'm not familiar, any more than I'm familiar with, for example, the H-28, which I've heard about but I've never actually seen. I don't profess to be any expert on vintage gliders, but I'm interested in old-fashioned methods of construction. In fact, here, possibly we can see, I have a photograph in my album, which maybe we can see, of an old friend of mine called Bill Manuel, who a lot of the people in the gliding movement will probably be familiar with. In fact, in that photograph he's sitting in a glider which I flew in wave to 8,000 feet. I was at that point 4,000 feet above clouds, which then closed in below me. But anyway, you can see therefore that I have researched the project fairly extensively, or extensively enough for my own satisfaction, and in fact out of the album has fallen this photograph, and this is a picture of my own fiberglass glider, which has been tested by the BGA, and in fact I understand that an article will be appearing in Sailplane and Glider in June issue of 1990 this year. So that covers fairly much the introduction to the project. As I suggested, it was proposed to me by a glider pilot friend, and as I was unable to proceed with my fiberglass project through lack of funds and the general lack of speed with which these things move along, I decided to take up the offer, because the H-17A is very much in line with my idea of the direction that gliding should have stayed in, as opposed to the direction that it's chosen to go, which is largely in the direction of competition. There are many forms of enjoyment to be had from gliding other than competition, and perhaps there is generally now an undertow of opinion that maybe there is some motivation becoming apparent to produce a more economical form of glider, as of course gliders were in the old days. And of course, having built or started to build this H17A, I find that of course the construction technique of that period had no consideration for man-hours, and in fact it's incredibly complex, massive number of components, and having spent a lot of my life simplifying that construction as far as I thought it reasonable to go, I now find myself thrust into a situation where I'm back to the old tradition. But it's a good tradition, a sound tradition, and a fascinating venture back into the past. In 1930, of course, my friend Bill Manuel was producing his Wren series, and they were very successful in England. Some were made abroad. He had the crested wren, the willow wren, and I believe another form of wren of which I cannot presently remember. But he sadly died a couple of years ago, and I feel very strongly that the building of this particular aeroplane would be a fitting tribute perhaps to people like Bill Manuel, who sacrificed for very little reward in their lives a huge effort to produce interesting and varied aeroplanes, without which I feel that our gliding movement would be sadly lacking. So it is with that in mind that I felt drawn into this project, and it is that fact which has provided me with much satisfaction as I work through the many hundreds of hours involved in this work. As anybody knows who's constructed an aeroplane, we are actually talking in terms of 1,000 hours to construct any form of sensible aeroplane. It's 1,000 hours of committed work. Quite difficult to sustain, as the evidence proves. The statistics show that very few home-constructed aircraft of any kind are completed by the original constructor. Having said that, the completion of these two particular aeroplanes will put my total of aircraft constructed up to a total of 9. So I have previously built 7 aeroplanes of my own design. This is a very interesting experience, having built so many aeroplanes, to then construct one of somebody else's design. And the intriguing part of that is that these drawings, which I was provided with, are quite remarkable in their accuracy. There have only been, I think, in the whole process, 2 areas of confusion, which is a very small quantity of doubt. But I suppose, of course, that to other constructors maybe there might be either less areas of doubt or more. There are certain areas where one needs to use a certain amount of initiative, but in general, this few drawings here are all that is required to produce a remarkably accurate version of an aeroplane that first flew in 1930. Well, we'll now go outside and have a look at the actual construction itself and the workshop involved. And it's important to remember, to those who say, well, it's all right for you, you have the facilities, you have everything you need, you've got the tools, the experience, and so on and so on. I actually live in a small terraced house, and a lot of the work was done in the attic, which I converted specially for the purpose, and the rest of the work is being done in the garage outside. So the idea that one needs a lot of facilities and a lot of space to build aeroplanes is a complete nonsense. Anybody who has the initiative and the incentive to do this kind of work also has Funny little thing. Right, do we have here is the wing former, the parallel part of the wing, from which all the wing rib jigs are made. So I'll just fetch one of those out. This is the box. The box in which the wing ribs are made. These are all just mounted. There you can see the wing rib former. The timbers are placed into these, and then they slide onto these guides. I have two guides here. Slides onto these guides here, so that the gussets, which are all positioned carefully on there, when this comes down on these guides, it stops the gussets from sliding. There's a tendency for gussets to slip off because the glue is still wet. So these all are made. That is screwed together to clamp the gussets into place. The next one is formed on here, and then another one applied on top, so on. So we have a set of three. 1, 2, 3. Exactly the same principle used on tail ribs for the wing. Not very expensive to create, but three sets of ribs at a time. Obviously the selection of the material becomes simpler as this is the selected timber involved, very straight grain, and these are fitted in here. The small members are cut in. And here are the gussets. Each one sanded, each piece sanded. On every diagonal. And this is fitted and glued, and the gussets all placed in position, like so. On some guides, very important, screwed down in 3 places. Of course, in 1930, we didn't have this wonderful tool, the electric screwdriver. 2 directions. So we use this to speed up the process. Right, we'll take a quick walk around the workshop. Now, this is the jig on which the fuselage is made, and we can see that it's made out of old scrap pieces of plywood, but the important thing there is that the top surface is completely flat. This jig is only 8 feet long, but it's big enough that the whole fuselage can be kept in shape during construction, because every part of the fuselage is curved. So without an accurate former, it's impossible to make the thing come out straight and true as we originally were intending. Now, we can see that the workshop is rather cluttered at the moment, most particularly by the second fuselage. Now, in order to get 2 of these into one small garage, one has to use space rather carefully. We can see here that this is just a normal garage, as you'll find around any housing estate. So we have one hutter upside down up against the ceiling, and one hutter on the building jig, which has now served its useful purpose. And here is the hutter itself. Part of the plywood covering is on. Soon all of this construction will be entirely clad in plywood and varnished. The resulting airplane will be clear fabric, as the old tradition, and varnished all over. This makes it very demanding on cutting of joints and fittings in general, because the slightest mark in the glue, slightest bit of damage, will be magnified by the varnish itself. This is where the wings are fitted on. We have 2 mounting posts there. The one goes on the wing spar and the other one goes on the drag spar to take acceleration loads and landing loads. And down at the bottom there we have the strut mounting fitting, which goes all the way across. If we look at it from behind, we can see that the seat fits through the bottom of the main bulkhead, and the strut mountings are linked by one bolt in the centre, which is just above the main skid mountings underneath. There's the seat that we were talking about earlier, and inside the cockpit you can see that this floor is actually oak veneered and will polish up rather nicely to match the instrument panel which goes onto this surface. Right, here we are in Hutterland. Two Hutters outside in the springtime, 1990. Since 1930, quite a few of these have been built in all corners of the world, and it's remarkable when you get involved with this sort of work to imagine people over all those years doing all that work. There go the neighbours. This tailplane is unbelievably strong. It's only 2 meters in span. And look at that construction. As we were talking earlier, the spar technique in this instance is magnified considerably by the fact that those diagonals connect and integrate the two structural spars within that tailplane. And without one of them moving, or rather when one moves, the other moves with it, so that the loads are spread evenly throughout the entire structure. That's where the rib that we were looking at earlier is placed. In fact, it's that one there. You can see that the thin plywood is ground off prior to receiving its fabric covering. All of this area and this area is covered in fabric. It's only this area here that the plywood covering goes over the leading edge. So there's a small curved leading edge and the rest of it covered in fabric. And of course there's vertical fixed fin, as normal, covered in plywood, 1 millimeter thick. And there's the other one. Probably not a very steady camera operator, but soon, hopefully, the skies will be graced by 2 more Hutters, each of them presently at the same stage of construction. This is towards the end of March 1990. Possible at an event such as this not to bear mention of the essential tool of the aviation constructor in wood, which of course is the electric bandsaw. Without this tool, it is hard to conceive of building an aeroplane, because all of the small components that we fit are cut individually on a tool of this kind. Again, well within the reach of the average person with an interest in building aeroplanes. And there we say goodbye to the hutters for the present time. Well, I hope you've managed to survive my awesome monologue. I had hoped a friend would come round to assist me with my interview, but unfortunately, as it's a Sunday, he's been unavailable. But a small insight into a very interesting and consuming type of work. I'd like to mention in passing that Hutter, apart from being a vintage glider, is not simply a vintage glider in the sense that it has old-fashioned handling qualities or anything of that kind. It's a much-loved aeroplane, admired by many, and has delightful handling qualities, which are no different now than they were in 1930. In terms of keeping wooden aeroplanes, which few gliding clubs presently like to do, the idea of the H-17, apart from being able to be constructed entirely in an ordinary garage, is that it can be stored indoors during the winter weather. Now, all wooden constructions survive much more happily indoors, which means that, assuming that the varnish is applied in the ideal conditions, there's no reason why that varnished surface shouldn't survive for possibly anything up to 100 years. Sounds extraordinary by everyday terms, but if the glider is used in reasonable weather, is kept dry and kept indoors, there's no reason why it should deteriorate at all. So the argument against wooden gliders is largely related to the fact that they are kept outside in bad weather. And whatever kind of ventilators you have on a trailer, the damp air affects the timber. Timber is very sensitive to changes in humidity. It's rather like a sponge. It will absorb any moisture which it can find. Therefore, the only sensible place for a wooden aeroplane is indoors in the winter. Now, to complete the story for the present time, I have with me here the instrument panel in oak, which I didn't actually apply to the machine whilst we were outside. You can see, possibly, maybe it's glaring, I don't know, but you can see that a polished oak instrument panel has its own special, or possibly eccentric appeal. And on that subject, I have to apologise for whispering outside, and possibly I whisper inside also, because the neighbours already consider that perhaps I'm slightly eccentric, if you like. Now, it's interesting here, looking at that instrument there, because this is in fact a hang gliding instrument. It's an electric variometer with two batteries so that you can switch from one to the other. And it's a very sensitive instrument that needs no flask. It operates with, is it thermistors, or am I talking about the old-fashioned type? Anyway, it's the modern printed circuit type of variometer, which works very adequately. I used it on my fiberglass two-seat trainer, and provides very satisfactory results, and in fact is the only instrument really needed in Otter. Once one becomes used to flying a machine of this kind, it is very much seat of the pants flying. The whole aeroplane weighs within 180 pounds. I personally weigh 170 pounds. So the Hutter it's not much heavier than I am. Presently the fuselages, as we saw outside, weigh just over 40 pounds. On the instruction sheet, which I have over here, on the general arrangement we're told that the glider weighs, if I can interpret my German accurately, the glider on its own weighs 68 kilograms, which in fact is the pilot weight. I'm wrong again. Zuladung is presumably the airframe weight at 90 kilos. 90 kilos is somewhere over 180 pounds. But I consider that the way that the weight prognostication is presently, I consider that it's likely that my aeroplane will certainly weigh no more than 180 pounds, in spite of being built entirely in pine. There's a tendency to build various parts of the airframe in different timbers, which I personally don't really like, because it involves more trips to the timber yard. So I'm building entirely in pine, which in fact is the denser of the materials and therefore the strongest. But in spite of that, the weight is coming out fairly satisfactorily at the moment. Well, I hope you've got some enjoyment from this program. I've been to a certain amount of trouble pulling everything out to make it. So perhaps if it works satisfactorily, maybe I shall make another film, and I shall certainly hope to have the video camera when test flying starts, possibly towards the end of May, possibly June of this year. There's a long way to go, but the wing ribs are now progressing well, so perhaps we shall see H-17A Part 2. Thank you for watching.